Okay, I hope my screen is visible to all of you. So this is the mock, and regarding the quiz one question paper, this is going to be the similar as this one. Okay, means the pattern, I mean to say. The question is may not same or different. It's depend on, you will see the question paper, but the pattern, I mean to say, you'll find some objective type questions. Along with that, some subjective type question would be there, and like as you are writing, I've seen we have checked the assignments of all student who is here, even who's registered this course. So many of you are skipping the steps of writing the solution. So please don't write such solution. Don't try to skip. Don't skip. The solution step. Write all steps. It will be good for you. Otherwise, some steps you are, hiding or something. If you are hiding, then we'll get that you are copying somewhere. So don't hide it. Okay, if you are doing rough work somewhere, rough right side or the back side, we'll see that would be also, scanned. So whatever you are doing, just do on the copy. Whatever the answer sheet will be provided, do there. Write all steps. Don't hide or don't skip any steps in the solution. Okay. 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 So in revision session, so quiz 2 contents are week 1 to 4 only. Okay. So 5, 6, and already 7 maybe you will see. But the syllabus is for week 1 to 4. Okay. And this is the first revision session. So we'll try to cover week 1 and 2. Before that, anyone have any kind of doubt?
Sir, in this revision, are you going to brush up the basics and then move on to questions, or are we going directly for?
So brush ups, or maybe a kind of, I will just to choose the topics and I will give that summary of that and move
Yeah,
on.
that should be fine. So
Yes.
just for what is called remembering that.
Yes. That's how we'll proceed. So I will try to cover week 1 and 2, and 3 and 4 will covered by Lavanya ma'am on Saturday, I think. Yes, it's already mentioned in the group. Okay. So topics in week 1 and 2 is knowing to be the vector space. We can skip the real numbers and complex number. The reason is many times you are doing so, numbers already familiar. Complex number writing to a plus I b j. So we'll see from the vector space. So from the vector space is we are playing on only R2 space. Okay. So we are doing R2 only. So vector space is, now many times all of you have seen that what is a vector space. Vector space is just a set. Okay, vector space is just a set. Here we are going to study the vector space R2 only, or maybe the subspace of that. So vector space is a set, okay, where some operations, addition and multiplications are defined with the some properties, like uh, the addition and multiplication needed two important thing. The vectors are nothing but the elements of this set. Maybe this is one element, this is second element, or points. If you think this is a coordinate system, so these are just points or the elements, you can say. And the property is that if we are adding these two, we'll get the element of this R2 only. It will not going to be any other space in the complex space. In the same within that, apart from that, if we are taking a set of this case x y, where x is equal to y, okay, this is a set. If the same operation here will define, so this will form another or different vector space. We can call it as a subspace of also subspace of R2. Okay, so this is a subspace, we can say. So um, before to go to subspace, I want to tell what is I was telling about the what is a vector space. So vector space is two main thing is needed. The elements should be closed under addition, and the second thing is when we are multiplying with a scalar here, when we are multiplying here with a scalar, so this will be also closed, mean this should be also within that set. Okay, these two things with along some more properties there, we are not going to discuss in that in more detail, because that is not needed. The question is also not asked to check which one is a vector space, so we can skip that. We just know that okay, such space is there, some elements or some that such space is there, and we call the elements of that space as a vector. Okay, the main thing is that talking about the linear combination. Okay, linear combination and linearly independent. Okay, independent and dependent thing. Okay, so what is a linear combination is that, suppose we are taking some vectors, okay, let's say 1 3 and 1 2, and we are multiplying, okay, with some scalars. Okay, with some scalar, and whatever after adding, suppose here I am writing 2 and here is 1. Okay, and whatever the vector it will be generated, we can say this vector is linear combination of these two vectors. Okay, this vector is linear combination of these two vectors. Okay, and the second this is the linear combination meaning. And if these two vectors, okay, if I am writing, suppose I have this vector 1 2 and 1 3. Okay, I have these two vectors, and I am just multiplying with the parameter a plus a times 1 2 and b time 1 3. Okay, I am equating it to 0. 0 means 0 0. Okay, then if you are we have already know solving the system of linear equation. So if you solve these two, if you are getting a is equal to 0, b is equal to 0, then this tells you that these two are independent. These two vectors are independent. If any one of them is non-zero or both are non-zero, then we'll say are dependent. These two vectors are dependent. So this is the definition of independent and dependent vector. Okay, the next thing is that span. Span is a word, okay, which is in the vector space, and span is called the span. We generally talk about a span of a vector or set of vectors. Okay, suppose same vector I'm taking. Okay, so I'm writing the span of these two means I'm going to collect all possible linear combination. Okay, I'm going to collect all. So this tells you all possible linear equation, linear combination, where AB I'm writing as a from R. So this tells you that, oh, I'm collecting. This is the collection here. This tells you the constant one, that I am any real number I am putting here, and I'm all collecting the linear combination. So I'm just collecting all possible linear combination of, okay, this one. So this set is called the span of these two vectors. Okay, and span is generally the subspace. Okay, now I'm using the word subspace. Earlier I used also. So subspace is a, we have a vector space. We are studying only the vector space R2. Subspaces are the subset of R2. Okay, this is a subset of R2, but the condition is that this should satisfy two condition. Okay, this set should be closed under addition. Okay, closed under addition and closed under scalar multiplication. If these two property hold by this set S, okay, where x is equal to y, I am writing, okay, this is a subset of R2. Okay, all of you know already what is a subset. So this is a subset of R2. If this is closed under addition, this is closed, and also the closed under scalar multiplication, then we'll call this as a subspace. Means whatever this set have, means R2 have all property of vector space, this subset also contain those all property. Okay, this is a subspace definition. So the span is actually subspace of R2. We generally are only studying the R2 only, the main superset or main vector space is R2. So span is going to be the subspace of R2. Okay, now whatever this subspace is generated, no, suppose I am taking this 1 2, okay, 1 3, and another vector 2 3. Okay, if you check it, or maybe this 2 5. So if you add these two vector, you'll get this 5. Okay, this is the meaning, means I am adding these two, then this 2 5s actually I am getting. So if suppose I am taking the span of these three, okay, suppose I am taking the span of these three, but I know this one is depend on these two, so I can remove, or I can write span only the 1 2 and 1 3. Okay, and you already said that these two are independent. So okay, so mean to say I am collecting only those vectors. I'm removing, removing some vectors from this span, so which are actually depend on the rest two. So I actually removed this one. Okay, so now I have this independent one. Okay, now I have the independent one. So this span is whatever the subspace is becoming. Okay, so these two vectors are going to the basis. Okay, basis means base element, means whatever the subspace you are getting, no, this one, these two only vectors are actually generating all elements of this subspace. So basis elements are those
So
elements
can we call this as a generator, sir?
yeah, you can call it as a generator. Yeah, you can call it as generator elements. So generator means, you, if you are saying the generator means don't skip, you don't call, means if you are calling only one, if you are calling only one vector, so call it as a generator, one generator element. If you are combining both, you are calling it, then you can say
Basis,
it's
yes.
a generator. Combinedly you can say this is a generator of this space. Okay, so this is the basis thing. So basis vectors are actually independent vector. Okay, now after the basis, what are the other topics we have? Span of vector space, linearly independent, and basis as dimension. Change of basis, this is one important thing. So okay, so change of basis. What is a change of basis? So suppose suppose I have vector. Okay, we will do the change of basis in R2 only. So suppose I have vector, okay, 1 2. Okay, now generally the basis will take of R2 is what? Anyone can tell what is the basis? Any two vectors you can tell which actually the basis of R2? Anyone? Anyone can tell? What is the basis? Any basis element you can tell?
How about 1 comma 1, sir?
Sorry, 1 comma 1 and next one?
0.
1
Yes,
comma 2
yeah,
you
1
can
comma
check.
2. Yeah, that's true.
Yeah, actually you can check these two are independent. So
Yes, sir.
this is a basis. There is another standard basis that is we are calling as a canonical basis, 0
Canonical. Yeah, 1001. Yeah.
and 1 0 and 0 1. Okay. So this is called a specific kind of basis or canonical basis. Okay. And this is any general basis. Okay. So this 1 2 is with respect to canonical basis is written like this: 1 1 0 plus 2 time 0 1. Correct? This is how it's written. If or any vector is given, let's say 5 7, so I'm not mentioning the basis, means it is automated that this is written with respect to the canonical basis only. Okay. But suppose I want to write this vector with respect to this basis. Mean to say, means this vector, these two are actually generating all vectors, or mean to
So
say,
when it is not mentioned, it is by default a canonical basis.
yeah, by default it is on the canonical basis.
If it is specifically mentioned, means we need to generate based on the basis set.
Yes. So here 5 7 means this is what it is. But similarly, I am saying this is also a basis. So can I find a where I am writing like this b time 1 2, which is nothing but this 5 7 is giving. So actually mean to say this 5 7 is, I can write this 5 7 with respect to this one also, because these two are basis element. So what is our here a and b? What is going to be a and b here? When it is 1 0 and 0 1, a, so here is, this is 7, this is 5. But when I am changing this one, what is going to be there? This a and b, what is going to be a and b? So to get this is a easy step. So to get this, just do whatever I am writing like this, no? Just write like this. You want to get this, so just open this two. Means here a, and this is b 2b, and this is finally a plus b and a plus 2b. Correct? This is what I am getting. Now
Right.
I am saying these two are same. That means what? This 5 is equal to a plus b and 7 is equal to a plus 2b. Correct? Now we are a system of linear equation. You can subtract these two. You will get minus 2 is equal to, here is minus b. That means b is equal to 2. And similarly, you can get the value here. You can get this implies a is equal to 3. Correct? So here we got the value of a and b. So if I properly write this 5 7 vector, okay, this 5 7 vector is written with respect to the basis 1 2 and sorry 1 1 and 1 2, okay, is
3, 2.
what? 3 and 2. Okay. This vector which is written with respect to canonical basis, this one automated that this vector is written with respect to canonical basis, but I want to write this vector with respect to another basis, this one. So this is how it is written: 3 2. The geometric meaning of this one is the canonical basis actually represent by only the xy coordinate, general xy coordinate, this tells you 1 0, or if you are vector, no, so this much is 1 0 and this much is 0 1. This is what the canonical base is. Okay. And 5 7 is somewhere here, so 5 is 5 times 1 0, so somewhere here it is, and okay, somewhere here is, and the 7 is going to be somewhere here, so finally here 5 7. But I'm changing the basis. Okay, So 3, sorry, 1 1 I am saying. So that means this previously this canonical is actually, these lines represent canonical basis, represent these lines. But when I am changing, so this will going to be 1 1 is going to be this one, and 1 2 is going to be 1 2 is maybe perpendicular. Maybe you can check on, even maybe different also. Okay, it may be somewhere like this. Okay, so x is slightly changed here, y is slightly changed here. So now we'll think about the coordinate of 5 7 with respect to this new coordinate. And 3 2 is going to be somewhere, 3 is going to be here and 2 is here, so 3 2 is going to be here with respect to this new one. So with respect to this new one, green one. Okay, so change of basis is nothing but a slightly change. We are changing or rotating the axis here. Okay, this is what in week 1. Okay, anyone have any doubt here till here? I'm recapping this is very fast, even because all of you many times we have seen this. So I want to know from your side that if you have any doubt here, particularly if you tell, that would be good to know you have a doubt. Anyone? No?
No, sir.
Okay. No doubt. Fine.
So
Yes.
if we want to find the new basis and we have to given previous basis, then how we will do this? Do this?
Okay. Suppose we have given 3, means vector given 3 2 with respect to the basis 1 1 and 1 2. Correct? And I want to
Yes, sir.
find this same vector with respect to another basis 1 1, or maybe 1 minus 1 and 1 comma 0. That is what you are saying.
Yes, sir.
Okay. So suppose this vector is given with respect to this basis. I want to find the coordinate with respect to this one. Okay, here is not mentioned that though this one is given with respect to canonical. Here it already mentioned that this is given with respect to this one. So first what we will do, we will first find this one with respect to canonical. Okay, so how we'll get this canonical with respect to canonical? So what it means that, see, I suppose with respect to canonical is let's assume this x and y means what, x time 1 0 plus y times 0 1. Okay, that is what with is with respect to canonical. Okay, sorry. Okay, so I just assume that, let's assume this is x and y. So what it means that this is x time 1 0 and y time 0 1. Okay, this is what the meaning with respect to canonical. So that is the same meaning if I am saying, okay, this is 3 2 with respect to this basis means 3 time 1 1 plus 2 time 1 2. That's the meaning here. This is what the meaning. So if I will solve this, no, this is going to be 3 3, and this is plus if you multiply, this is 2 4, and finally we'll get 5 7. So whatever you will get this one, this is actually the original wall vector, right? So this is what, if you substitute this coordinate, okay, this coordinate with respect to this basis element, whatever the evaluated vector you will get, this is with respect to canonical basis you will get. Means once you substitute the coordinates, you will get with respect to canonical basis. The reason you can see it here also. See, I this 5 7 equated and then solve a and b, I got 3 2, no. So if I will substitute, I will back to the canonical vector, right? So once you substitute the coordinates in the this, so coordinate in this basis, you will get a vector which is actually given with respect to canonical basis. Getting it? Is this clear?
No, sir, a little bit confusing.
Little bit confusing. Okay, let me try it with the different
You mean to
method.
say the calmness is also true actually, like when you are when you're changing the basis and then we are doing with respect to 1 comma 1 and 1.2. So the vector on converse using this operation we get the canonical basis.
Yes, actually,
Okay.
see. Okay, let me back to the same steps here. See, I got 3 2.
From the basis of vector, the
Yeah,
canonical
get
basis.
3 2. What I did this, I write 5 7. Okay, and proceeded like this, and finally got a is equal to 3, b is equal to 2. Okay, this is what I got. If I will back to the step, just back to the step, so I will end up with this one, right? If I will exactly back to the step, means a
Yes,
equal
sir.
to,
Right, sir.
or maybe not, even I'm saying to the back step, maybe not, maybe that means here back to the step means, or in different word, I actually use this one, this 5 7, I equated to this one and got the value of this 3 and 2. Okay, so this a value is 3 and b value is 2. Okay, when I am substituting this the whatever the basis is given, okay, this is what I am getting. No, this 5 7 will get, not clear in, I think. So let's not connect with this one. Okay, I'm writing another. Let's say this is a element is given with respect to the basis 1 1 and 1 2. Okay.
So can you explain with the activity question? That is first activity question of this I asked activity 9.
Okay, no, not this one. Which one?
So it's week 2. It's in week 2.
So this is in week 2, no? So we are change of doing here only, we are doing the change of basis with respect to only uh not, we are not going to do for the linear transformation. There is another change of basis with respect to linear transformation, means what is going to be the matrix representation with respect to another basis, that is also a change of basis. Here with respect to vector we are doing only. So these two things are there. So there are, if you see, two words are written. One in first lecture, change of basis is here is written. In week 2, another change of basis is written. So this one is actually for linear transformation. Means I want to find the matrix representation of a linear transformation with respect to another basis. Okay. Here, the first one is actually this in the lecture 1. This tells you that is for linear transformation. No, this is for same. This is for vector. Means I have a vector. I want to get that vector with respect to another basis. So there are two things. Let me write here. Then it will be more clear. One is for vector. So vector one is for the first one. First in lecture 1, lecture 9 is for vector. For vector. What is the vector? Find the vector, or write the vector, or maybe this is be good. Write a vector with respect to another basis. Okay, and the lecture in the week 2, lecture last one is whatever the lecture, whatever the last one lecture, this is for linear transformation. Okay, linear transform, what is there? Write the matrix representation. Okay, matrix representation with respect to another basis. So words you can associate or match. Another the same word with respect to also same. In place of vector, here is matrix representation. Okay. So this is two things. So we are doing here. We are doing here. This is, I have a vector is given. I am writing this with I, this vector is given with respect to this basis. I want to write this vector with respect to another basis 1 1 or maybe 1 minus 1 and 1 0. Okay, we'll see there. So this is for vector only. Okay,
Yes, sir.
so these two things are clear.
Yes, sir.
Yeah, yes, sir.
Okay, now let's do this one. I want to find so this 1 2 is given with respect to this basis. Okay, I want to find I want to write, or I want to find this vector with respect to this basis. So how we'll do the processes, you can remember even. So what I will do, this vector is given, so this one time this one will take, and I will write with respect to here 1 1. Okay, plus you will take this 2 here and you will write here 2 1 2. Okay, if you do this one, you will get here 1 1 plus 2 4, and finally you will get 3 and 5. So whatever you got this one, no? This one is with whatever this vector you got, this vector is with respect to canonical basis. Okay, once you substituted this coordinate with respect to this vector, whatever the obtained vector you got with respect to canonical basis. Okay, with respect to canonical basis you got. Now once you have this canonical, change now with respect to this one. So now this 3 pi you will take and assume that a time 1 minus 1. Now I am writing with respect to new one, this one, a time 1 minus 1, b time 1 0. Okay, this is now if you solve this, this is going to be a minus a, okay, and plus b 0, and this is a plus b minus a. This is equal to 3 5. Now a plus b is equal to 3, and minus a is equal to, sorry, yeah, minus a is equal to 5. So here a is equal to minus 5, and this will be give b is equal to 8 also. So now this, so that means a is equal to minus 5, b is equal to minus 8. So this 1 2, okay, with respect to this basis is what? Minus 8, sorry, what is that? Minus 5 and 8, minus 5 and 8. This is how you will proceed. First you will, whatever the vector is given, you will convert that in the with respect to canonical basis, and then back to find the new one. So this is the steps to do. Now is it clear?
Yes, sir.
No?
Clear, sir.
So that's how you will do. Okay, so this is the change of basis. Okay, so whenever a vector is given different from canonical, okay, you will use that to get, okay, you will use this here to get with respect to canonical, and once you got again canonical, then use that to get this one by this process. Okay, so this is a kind of loop, you can see it here. Okay. So this is a change of basis with respect, this is change of basis of vectors. Okay, now in week 2, what is in week 2? Week 2 is a linear transformation, I think. It started from linear transformation, inverse of linear transformation, null space, matrix representation, linear transformation. Till here, anyone have doubt in the vector space case, basis, dimension, span, change of basis? So here is the one question here. This one. V is a vector with respect coordinate this one. What is the coordinate with respect to canonical one? So what you will do here? Anyone? With respect to canonical, what you will do? The third problem.
Take 2 and multiply with the coordinates of u1, and then take 1 and multiply with the coordinates of u2, and then add.
Add them. That's all. That then finally will give your the coordinate with respect to canonical one. Just now we discussed one. This is one problem, the same activity problem. But I have some extra added one. The new one I also added. Otherwise, if you take these two, this one, multiply with u1 and this take 1, multiply with this here and add them. You will get whatever the solved vector you will get, that is your vector with respect to canonical. Okay, so in our case, it's actually the same problem till here only. This is the same one till here only. This portion is new one we have seen, means added in my question. And so you can see just uses this one to this and then got this one. This is the vector you got with respect to canonical. Okay, so this is what the canonical. Next is linear transformation. So linear transformation is nothing but a kind of map, a kind of mapping function. Okay, but this function have a specific type of property. Okay, this property is that some more property that this mapping is from a vector space to another vector space, and it have a property that if I'm taking two vector v1 plus v2, so it will be linearized here. So that's meaning here linearized. So this is one part of linearize with respect to addition, and with respect to scalar multiplication is c c time tv. If these two property hold by a mapping, by a function, okay, which is with respect to vector space to another vector space, then we call it as a linear transformation. So why we are studying this? The reason is linear transformation can be converted in the matrix form. So the matrix, you know how much useful matrix is very useful to getting the eigenvalues, eigenvector. It actually help you to once you will study the that what is called Fourier series, there you will see the use of it. Okay, basis what you will see there, the Fourier basis is there. So these things we will see later. Okay, so this matrix, this linear transformation is actually formed by the can we convert it as a linear transformation, that is called a matrix representation of this linear transformation. Okay, so for example, I am writing t of xy. Okay, this is a vector v. Okay, v is nothing but xy. So let me write t of v, which is x and y. Okay, the map is given like t of, so this is x plus y and x minus 2y. Okay, okay, if you check these two are already satisfying, we have seen in the session also. You can check these two will this will satisfy. Okay, so this is a linear transformation. Okay, now the property is that I can represent this linear transformation in the matrix format. So to represent this linear transformation in matrix format, so I need a basis. So this question would be like this: find the matrix representation of T with respect to this canonical basis. Okay, so with respect to the canonical basis, the matrix representation here is going to be what? Here is the process is you will find the image of the first element. Okay, T of 1 0. First you will find T of 1 0. The image is going to be 1 and 1, and T of 0 1 you will find the second one, T of 0 1. This is going to be 1 and minus 2, and the matrix is now easy. I don't know, many people you find difficult. Now whatever the first one I got here, this is in the horizontal form, no, right? In the vertical form 1 1. Again this is a horizontal form, right? In the vertical form 1 minus 2. That's all the matrix representation of T with respect to canonical basis. Okay, my question is find the matrix representation of this T, okay, with respect to another basis 1 1 and 1 minus 1. With respect to this basis, I want to find the matrix representation. How we will get this? What is going to be? Anyone? How we'll find here?
Yeah, in place of 1 comma 0 we'll put 1 comma 1, and in place of 0 comma 1 we'll put 1 comma minus 1.
Okay, let me do it. 1 comma 1, so this is going to be 2 and minus 1, and t of 1 comma minus 1, this is going to be 0 and 3, correct? 1 minus 2, yeah. So what is that? Now you will just write directly vertical form. This is 2 minus 1 and 0 comma 3. Is this going to be, or have to do something more? Anyone?
So do we have to change to what's the canonical base and then come back to this one, right? Basis change.
Yeah, so actually the thing is that you got this vector, okay? So I use this one. So I didn't mention here is two things is need to note here. I didn't mention the basis for the domain 1 and codomain 1. I said the matrix representation with respect to this one means whatever you will use this basis for the domain 1 also and codomain ones also. Mean to say, I found the image here, okay? This one. Now I will express this with respect to the basis whatever given 1 1 and 1 minus 1 with respect to this one, these two. Mean to say, this vector I got, now express this 1 a 1 1 plus b 1 minus 1, okay, and find the value of a and b, and whatever the value you found a and b, that is going to be here, okay. Similarly do for this one. Let's say this is a prime 1 1 plus b prime 1 minus 1. So whatever the value got here, this should be like this in horizontal vertically form. This should be written. Now can you tell me, can no one going to ask why this I am doing? Can anyone or getting it? Anyone want to ask why I'm doing like this? No?
Because the equation, I think the equations are with respect to the canonical basis that we are.
Equations. Which equations?
Yeah, x plus 2y and x minus 2y.
That is, yeah. This is a good answer. This is a good answer in one word.
So initially it's a canonical basis. From there we are expressing in this basis actually.
Yes. Yeah, so the second answer, your answer is also correct. Whatever we are getting, no, this we are getting with respect to canonical basis. We have to convert this to our basis where we want to find. Okay, and also he said correctly actually. So this is expression is given with respect to canonical basis. I didn't mention, but then transformation generally somebody is given. No, it is automated, understood, or you can automate that this is given with respect to canonical only. So you have to convert. So whenever change of basis is happening, you have to do like this. Or another method is also there. Now the last lecture I will just jump there, and this here I will tell you. Okay, so this is now here it's a change of basis, okay. So here it's actually happening, okay. So what is happening here, I first found the matrix representation with respect to canonical basis, which is this one, okay. And I am saying, okay, now I am trying to find the matrix representation with respect to this basis 1 1 and 1 minus 2. Sorry, 1 1 and 1 1 1 and 1 minus 1, which is here this one. I found the image. So whatever I did this one, I said get to and write like this. This is the matrix representation. But without doing these all, you can skip. You can skip. The way is that how you can skip. The skip word is use this original one and to find this one. Okay. How we can get this? So simple formula is there. Okay. The formula is the formula is uh, uh, this basis you will take, okay, take this basis, okay, form a matrix, so I form a matrix. I wrote this basis in a vertical form here, 1 and minus 1. I wrote this one, okay. Now this matrix is this one, this matrix is here, and now this canonical one, take this canonical one, Okay, 1 1 and 1 minus 2. Put here 1 1 1 minus 2. Okay. Now another one is going to be here, the inverse one. Let me check I am writing a correct thing or not. So once I will correct, I will tell that do the process is this one. Formula, where is the final formula? Okay, the previous one, the inverse one will go. Sorry, yeah, this one. Okay, so here it is the formula. You can check. This is the change of basis is happening. So see this one. So whatever the basis you use, this one right here, okay, and right here also 1 1 1 minus 1. Okay, but the thing is that here whatever the matrix you got, okay, inverse of that here. So find the inverse of this portion, okay, and do all the matrix multiplication. Whatever you are getting this A prime, B prime or AB here, this is going to be the same, this one. Okay, this is the change of basis with respect to, sorry, this is the change of basis for linear transformation. I'm actually finding the matrix representation with respect to another basis. Is this clear? This formula is clear?
Yes, sir. But which one we should use if they ask in the exams like linear transformation using matrix method means we have to use this one, or can we use this one also, the other one?
Where, which one formula you're saying?
No, for exam, in the exam point of view, when they ask for the linear transformation change of basis means, then in the matrix representation, do we have to put on the second one that matrix inverse and matrix multiplication?
This will be fine. This formula you can use.
Or we can use the old one also, the other one.
This one.
Yes.
So it's totally depend on you. If you are writing the steps in solution like this, I'm not going to deduct you because this formula is generated by this only.
Okay? Yeah, that is true. That is true.
So this formula is generated by this only.
So here in this case, we have to find the inverse, right, first actually, and then multiply it with them.
Yeah. So inverse formula is very, very easy. Okay. So inverse formula is easy. A, B, okay, A, B, C, D is there. So inverse of this one is going to be 1 upon, you can remember, okay, AD minus BC, and here is, what is that? This is D here, and this is C here, and this is B here, and this is D here, but somewhere is minus. Where is that? Here and here minus. Yeah, I think so. These two places are minus. That's all. You can remember twicely, right? You will try twicely, thricely.
So is it a D or A, sir, in the last one? Last element.
This is here minus.
I mean, like it's a D or A.
So here is, this is A. Sorry, this is A. I think this is correct. Inverse of this. You can check the formula. Okay, this is nothing but the adjoint is called. This is called adjoint upon the determinant. So this is,
yes, adjoint actually, yes.
So this is the correct. I think so. You can check even from the lecture. So this is what's happening. So no need to do a very, very long thing. You can just use this formula. This is totally correct. Otherwise, this formula is obtained by this method only. So if you write these steps, that is totally correct. So this is a good one. Practice 2. So this is the change of basis we combinedly studied. We combinedly discussed here for the vector also for the linear transformation. I hope both are separately and also clear. Okay, both are separately clear. Okay, this is the change of basis, and now we want to discuss rank and null space. Now, yes. Anyone have any doubt? Yes.
I doubted that the exam is pen and paper now, or it's objective.
No, pen paper only. Pen paper.
So to type on the monitor screen, or just we have to provide the
take your pen and say it rough. Means hard copy means paper. It will be provided a paper. Okay, they will provide TCS. TCS employee will provide you, paper, and you write with using pen only.
Yes, sir. The question will be what is presented in the system, and we have to write the paper.
Question paper will be on screen.
And system, we have to write it in paper actually.
Yes, if it is objective in there, okay. So as you are doing, no, as you are doing in for the graded assignment, you are used to see the question paper in your computer and used to write the all for objective subjective on your paper and scan that and send. So scanning thing will be done by the TCS. So you just need to write on paper and submit to the TCS.
Okay.
So they will
One
actually
more
take.
doubt, sir.
Yes.
Uh, there are some questions, MCQ questions in the means graded week 3 assignment or week 4 assignment that are subjective. So
Mhm.
we have to answer one options, or we have to oh, answer that how the answer has come and how we conclude this option, or that like that.
So for the objective one, if you are writing the step, it will be benefited for you to that if you suppose you don't know the correct option, but you wrote the steps, okay? And this will be
Okay, so
good for you that, okay, if you are writing the steps, so we know that if you are tried but reaches to the wrong option, but we'll try to give some step. If you are very much sure that this is the correct option, you can write directly the correct option. There is no matter. If you are writing only the options, if you are writing
yeah,
the wrong
that
option, I will give you the
that
0 mark. Okay. If you are writing the wrong option with the correct option, I will give 0 mark. But suppose if you are writing the steps with the with the wrong option also, we'll try to give some marks, partial marks, not partial, exact partial, half of 0.2 or 1.
so if we will write only the answer and the answer is correct, we do not write anything solution, then also we will get full marks no, for objective
Also
questions
will get
at
full
least.
marks. If you are not writing the steps, you will also get the full mark. But if the option should be correct only in that case. If you are writing the wrong
ठीक
option,
ठीक
then
okay.
mark will not given 0 mark directly.
Okay, okay.
So this one is provided for who having doubt, means not clear with the option, but he has used to solve some steps and reaches to the wrong option even, but may get because we'll see. Okay, you are writing, but you are not reaching to there. If the steps are actually in the on the way which to solve actually means to getting the correct option, uses those steps only, then marks will be provided. Some marks, not only I will say half marks, some marks will be given.
Okay.
Okay, so this is the okay, so this is the for exam only. Okay, so let's discuss the rank and range. Okay, rank and range are two different word. Okay, don't mix up with this. Range is actually, see, this is a mapping, no? So whatever the output you will get, that is called range. Okay, and collect all outputs, you will form a set, that is called range space. Okay, space means you will check this set, this is actually a subspace. So that's why it is called range space. Okay, and if it is a subspace, it have some basis. Okay, it have some basis, and number of element in the basis called the rank of. Okay, how many elements are need to, okay, to generate this whole range space is called the rank. Okay, means number of element in the basis of this subspace is called rank. Okay, so rank is just number, natural number you will get. Range space is a subspace. Okay, so somebody says that range space is, what is going to be range space? So suppose this expression is given x plus y and x minus 2y. Okay, so range space is nothing but, there are so many ways to write it. So range space, if you are writing like this, x plus y, x minus 2y, this is totally fine. Okay, where x and y belongs to R. This is a range space. Or somebody, but the question is find the basis of it. So you have to find the basis. Okay, you have to find the basis. So to find the basis, what is the way? The best way is find the matrix representation. Okay, and find the column space of it. Sorry, column space. Sorry, basis of the column space. That is the basis of nothing but range space. Okay, so what I mean to say, find the matrix representation and find the column space. Column space you will find, you will write some span of, some span of that. Those columns, whatever the columns you will use to find, you will use to write that, column space. Those columns, this is nothing but the basis element of range space. So you can write the basis by this way. That's the only good thing to write this. Okay, this is the range space. Okay. So what is a nullity? Nullity and null space is there. Null space. So null space is, again, what is that? Actually, suppose I have a linear transformation x plus y and x minus 2y. Okay. This is a linear transformation I have. And I want to find the null space of it. Means I want to collect those vectors, okay, when I am fitting in that, okay, I mean to say those vector v, when I am fitting in this linear transformation, I am getting 0 element. 0 means here 0, 0. Means I am collecting those vector which have 0 image. Okay, that is your null space. So here the null space, to find the null space is two way. Either you can first find the matrix representation, which we have already find, 1 1 and 1 minus 2. Okay, this is the matrix. And now find the null space of this matrix. So null space of this matrix is the way is that find the null space is simply you will just solve this system of linear equation. Okay, so if you solve this, you will get here what? X plus y is equal to 0, x minus 2y is equal to 0. See that this is x plus y is here the same, this is x minus 2y is here the same. So writing in the matrix form and solving this one is better to, just expression is given separately equated to 0. Okay, and you will get a system of linear equation x plus y is equal to 0, x minus 2y is equal to 0. And if you solve these two, you will get minus y is equal to 0 and x is also 0 you will get here. So means null space is just a 0, 0 here, 0 space. Are you getting it? Means either to convert the matrix form and solve this, in place of that you just take the coordinates here, this one expression, this one separately equated to 0, you'll get a system of linear equation, this one, solve that, that is yours. That is what here it's happening. If you check that these two are same here, this one and this one, or here whatever the here writing, these two are same. So either by do this way or this way, both are same actually, and you can solve that and get the solution on that is your subspace, sorry, null space. And once you find the null space, means suppose this is here, I am writing another system of linear transformation. This is x plus y and 2x plus 2y I am writing here. So null space, to find the null space, just separately equate to 0 here. So this is x plus y is equal to 0, 2x plus 2y is equal to 0. Okay. And if you want to do with the matrix representation, matrix is going to be with respect to canonical basis, this is 1 1 and this is 2 2. This is 1 1, this is 2 2 by column row. Yeah, this is going to be okay and equated to 0. And if you check, this is x plus y is equal to 0 and 2x plus 2y is equal to 0. This is what you have using the matrix, and see that directly here it is I am reaching. So you can go with this one or you can go with this one, both are same. Let's solve this. So if you check, these two are x plus y actually giving x plus y is equal to 0 only. That means null space is those vectors, okay, where x is equal to minus y, or here x plus y is equal to 0. This is your null space. But find the basis of it. To find the basis is how we'll write. So here x plus y is equal to 0. So here x is equal to minus y. This tells you y is independent. Only one independent vector is there. This means that the one vector you will get here. So if you substitute y is equal to 1, you will get x is equal to minus 1. Sorry, this is the vector. So basis is going to, for the null space, is going to be minus 1 and 1. This is the basis. Okay, and nullity is just number of element in the basis. So this is one element, so nullity is 1 here. Here previously we got the 0 subspace only, so nullity is 0. Okay. Is this clear? The two ways we discuss and null space, nullity.
Yes, sir.
No?
Clear.
Any doubt? Many times we are doing, so I hope this much is clear. If you are writing, no, see this is the benefit of the subjective assignments, that if you write your own way to, if you're writing your own solution or submitting the assignments, all of anyhow will get that. So easy, these are the easy steps. So nullity, rank, or I hope this is clear to way to solve this. This is the null space, okay, and nullity, and the basis, how we'll find the basis. We have discussed with the 2 examples. And what are the other things are there? We have discussed the change of basis.
Sir, can you explain the linear transformation of a line?
Sorry, linear?
Transformation of a line. Line to line.
Line to line. Okay.
Yeah.
Okay. Rank, null, rotation is there. Matrix representation we discuss. Linear transformation discuss. Only need to discuss composition and inverse thing. These two remain. Okay. So line to line is means what? This see, suppose we have a linear transformation, okay, and you are saying suppose we have x plus y, x minus 2y. I have a linear transformation. This one. You are saying line to line means I have suppose I have line x plus y is equal to 2, one line, and another. Okay, this is line. So what is going to be if you transform this with respect to this? What is going to be that line? Is this the question?
Yes.
Okay. So if it is this question, so the simple way is that first think about this line as a vector. Okay. If you want to write this line as a vector, how we will tell that? So if you means point as a vector means as a point. So you can think what as a point if you will think. So point wise if you write this is x, or if you point wise we just change because of here is also x and y, here is also xy. So for the time being just change as what is this? If you assume x is equal to v1, so y is equal to what?
2
2
minus.
minus. So as a point wise you will think, so here what? This line is nothing but v1 and 2 minus v1. That is what your line, right? Now you apply here t of here this one. So this is v1 and 2 minus v1. If you do here, this is what is this? V1 plus y is our y portion is 2 minus v1. The second is what? Sorry, plus is there. Yeah. Okay. So v1 and minus 2 time 2 minus v1. This is what it is. And the finally you will get here v1 will cancel out. This is 2. Okay, and this you will get here minus v1. Sorry, v1. This is going to be what? This is v1 minus 4 plus 2v1. So 3v1 minus 4 you will get. This is, if you transform this line, you will get this vector. So this means this vector you will get here. So now if you want to represent as a line, so what is that? This is our x2 and y1 is 3 of v1 minus 4. Okay. So now find the relation in between these two. How will get the relation? If you transform it here, what is going to be the relation here? Relation is between x and y is what is going to be here? This v1 is erased from here, no? So that's the problem here. Otherwise, if you're writing like this even, that's totally fine. This is the line actually representing the line. This is x is equal to 2 and y is equal to v1.
So, but our in our exam or test actually it is the point form, right? Not the line. So do we have lines?
No. You just ask and I
Oh,
started.
okay.
So no need to worry it, but that's how we'll
This is
proceed.
the
Okay.
reference actually for what is the knowledge basis. Yeah.
No, no, not needed even, not needed. This is all I just for the for his interest I discuss. Okay, either if you're writing like this, that's totally fine, or this is I don't think I made a mistake somewhere. Maybe just need to find the relation between these two. You'll get easily relation. I
Okay.
this time maybe okay. This is how the way to find. Okay.
Okay.
Uh, this is okay. So you can skip. No need to come in the exam. Okay. For this is not going to be. This is a bit tough even.
Sir, can you repeat only for a span actually? How to find a span for a vector?
A span for a vector
I mean, like for yes.
means we have a vector. This one, 2. You want to find the span of this.
Yes,
What
sir.
is so a span is okay. So a span you want to find some expression. Okay, this is a good thing. So in this span is nothing but what? So this span is what? This is here the collection of vectors. This is what if you write here. So this is the meaning of the span, right? This is the meaning of a span. If I'm writing like this, even this form, span of 1, 2 is this one. This is the meaning of in the set form. Sorry, this is the meaning of in the set form. Okay, so this is we have. So this is A and 2A, and this is A belongs to R. Okay. Now assume this is our x and this is our y. Okay. So x is equal to A and y is equal to 2A. So what this tells you? What is the relation between these two AA? Y is equal to
Okay.
2x. This is your span. Okay. This is
Okay.
span. That's how you should proceed. This will be more easier. So I hope it. Yeah, this is a good thing. Many times, and in assignments also, you have seen this kind of expression. Means a problem would be like this: span is equal to what? X and y, where y is equal to 2x. So in options, it will be given like this. So this is the way you can follow to find this one. Sorry, to find this one. Okay. Either you see the second thing is if it is an option wise it is given, no, so you can check this vector actually satisfy the equation. Okay, this will satisfy. You can check if you substitute here x is equal to 1 and y is equal to 2, you will get both side 2 2. So it will actually satisfy. So this is a way to check or verify also you are reaching to the correct answer or not. Okay, now let's discuss composition. So composition is a kind of twicely you are mapping. Means I have a linear transformation T, I have another S. So let's say T of xy is given something x plus y and just x, and S of xy is given just x plus or maybe x minus y and 2y. So this is the given. So composition T of S is this one is nothing but T time S of xy, not T times T an inner part argument. This is called argument here. T argument S or T of composition of S. This one. So this S of xy is given as a T of S is this one is given. So this is x minus y and 2y. Okay. Now this is your one part. This is another part. So like this will behave like this is x. This part we have like x here, and this part we have like y here. So means finally if we do here, this is going to be x minus y. Okay, this part is there, and now plus y. So this will be added here plus 2y. Okay, now this is just x. Sometimes in the options is usually ask also this is going to be x plus y and x minus y. So this is the composition. This is how we'll get the composition. Okay, and sometimes the question would be find the matrix representation of this composition. So composition to find, first you can, there are two ways. Either you can find the matrix representation of this T, okay, which is A, and matrix representation for S, which is B, and now T of S is saying, so means A time B. Okay, find the matrix multiplication A time B. Or S of T is asking, so B time A. B is for, B is for S and T for A. So B time. If it is T of S, then multiply like this, and if it this. Okay. So matrix representation of T of S is the multiplication, this one, and S of T is this one. This is one way. Or the another way is finally find this expression T of S, which is here. And now the find a matrix representation of this expression. And the reverse part, S of T, you can do the same way. So there are two ways. You can proceed with this way or that way. And the now canonical, range null is once you find the matrix, you can easily find the range null all. Okay. This is what the thing. This is a composition. Now inverse is, we have already discussed how to find the inverse of a matrix. But inverse of a linear transformation is what? Suppose we have a linear transformation is given. Okay. This is a linear transformation is given. So inverse is that linear transformation. Okay. If you compose with this, you will get just xy, means identity expression, the same. Or TR inverse of the reverse part also. This is going to be the same identity transformation, which is nothing but x and y. The same vector you will get. Or if it is the problem you are facing with the x and y, just v is there, I of v, means same v will get. Okay. So this is the inverse thing. The same method you can follow to find the inverse one. Or the simple thing is to, whenever somebody says they find the expression of this one, what you will do? Find the matrix representation of this one. This is going to be 1, 1 and 1 minus 1. Okay. You can easily check. Okay. Many times if you do practice, you can directly write even. So this is a matrix representation. Now find the inverse of it. Inverse is going to be what? 1 upon AD minus BC. So AD minus BC if you'll do, you'll get minus 2 here actually. And now this will be D will be here. So this is minus 1. Okay, minus B here. So minus C here. So this is minus 1. Minus B here will be, B is here. So minus B is here. So which is this minus 1. And A will be here, which is this one. So A will be this directly. So this is the inverse one you got. Now what is the next step? He found actually the question asking the expression, no? Just do matrix multiplication of x and y. Now finally 1 by 2, write this expression. This is going to be minus x minus y, and this is minus x plus y. This is the expression of this inverse part. Easy? Is it easy? Not tough? Or not clear?
Yes, sir. Easy, sir.
Easy, no? So
Yes, sir.
So getting what the steps to find the inverse one, inverse expression, inverse matrix representation. The best way is, I will suggest you, please remember to find the matrix inverse A, B, C, D. Okay. So if you find the inverse this is A, B, C, D. So AD minus BC, and this is A minus B, minus C minus B. So this is T here, and this is A here. You can remember this formula and directly find the inverse, and now find the expression. Then after find the expression. This is what I did here. And now multiplied with the x. Right? Yeah.
Hello.
Yes,
Sir, I
yes.
think it will be minus B and minus C in place of minus C and minus B.
Here is, here is, where is that?
In place of minus C, it should be minus B. And
Yes, yes, minus b. Yeah, in the inverse one. One
Here is
last
minus
minus.
b.
in the inverse, yeah. Uh, yes.
Okay. Okay. No, I don't think. Okay, I suppose let me A, B, C, D. So first let's find the adjoint of it. So adjoint is going to be, I will take this one. So this is going to be D here. I will take this. So this is no, this is the correct one. If I'll take this one,
Oh, this is correct, sir. Actually,
so this is correct. This is the only one. This is C here. This is B here. This is correct.
no,
And now,
sir. I mean, like minus c instead of minus c, it's supposed to be minus b, right?
yeah,
Yeah. We have to take the transpose, na? Transpose of
Transpose over there, sir.
yeah, that is
Minus
what I did the transpose. That's why I'm writing here in this vertical form. I already doing the vertical. I mean doing the transpose. Otherwise, I will write here. If I will do here, okay, okay. Suppose doing this here. So for A, this is D here. So D will be here. For B, okay, this will be C here. Okay. For B, this will be C here. So C did I did here C. Okay. Now for C minus C. Okay. For C, it will be minus B and A will be A here. Now I will do the transpose of it. So this is going to be, transpose is going to be D minus C minus B A. Okay. Yes, yes. Okay, okay. Okay, this is minus B minus C. Is it? Oh, so this is minus B. Okay, okay.
Now it's right, sir.
Yeah, you are correct. So yeah, this is in place of B. This is, I think interchange of between A and C. This is going to be the same. Okay. Yeah. Sorry, sorry. So please check the formula. I think yeah, now it is I think correct. You previously whatever you were saying, that is, yeah, this is the same, minus B and this minus C. So in place, yeah, maybe, yeah. Sorry. I've just, so A B C D is there. So directly you can write 1 upon AD minus BC,
Because
and
that's the adjoint, right? So that's why
yeah.
we should not put.
So here it is D, and interchange between A and D, and C and B are going to be the same with the negative. Okay. By this way you can remember even. So change between A and D, and B and C are going to be at the same plus but with the negative sign. Yeah, sorry. So that's why many times I'm saying please check. Sorry. When I made by enjoined, so I thought maybe this one. Okay. Okay. So this is the inverse way. Means we can find the inverse of a linear transformation. So I think in the lecture already professor is mentioning what is the inverse. Also. No, I think I'm making mistake here. See that the inverse is here. This is the main standard. If we are making a mistake, okay, so if you are making the mistake, this is the final one. Okay, maybe I transposes that. Maybe I mean. So this is the inverse here. Okay, so we can remember. So interchange between these two and these two also. So, but yeah, this is that's why you are saying okay. So this AB is here and CD is here. Then the inverse is this one. Okay, so I am writing by that way. So that's why I am doing this. Okay, and this is what here. So okay, if this is the matrix, then inverse is this one. Okay, so please do by this standard form. Okay, this is the correct one.
Getting A, B, C, A and B is different form actually. So that's the reason we are getting different.
Yeah, that's why I bit confused otherwise. Okay, so check this one. This is the standard
But
one.
either way, it's same, sir, actually, because if you do that, what is called as changing the element of this,
Interchanges between this diagonal one and non-diagonal are going to be the same. C is here, C is here. Okay, so this is minus C, this is B here, this is B minus B. Okay.
okay, sir.
Okay, this is what the contents are. I hope I tried to convince you how it is all, and very fastly I actually solved. But I hope many of you are catching it as we are discussing it. So that's all. Anyone have any doubt? Please let me know any kind of operational query or anything. I'm here. Discuss that. Topic wise, at least I have tried to cover week 1 and 2 almost. I have covered.
Hello.
Yes.
Yes,
Yes,
sir.
Veba.
I have couple of questions in activity
Mm-hmm.
in week 2. Like,
Mm-hmm.
just a second. Okay, sir. Activity 9, question 1.
Of which activity?
Week 2.
Of which lecture?
Activity
Activity.
activity 9. 9.
Okay.
Question 1.
Okay. Okay. This is okay. Fine. Consider a vector x. This find x with respect to canonical is already given. Yes. So what is the doubt here?
Okay, so sir, my answer is option A, but it seems wrong.
Okay, this is 2, 2 and 4, and this is 2. This is 2. This is 2. This 2 and this 2 and 5. So option way. So what it is option? Option A is correct actually.
B.
Which option is actually here says? Oh, C.
Yes.
Yeah, this should be 5. So this is just multiplying. Yeah, correct. So this is A only. So this 2 and this 3 because minus. So no, sorry. This is minus 1, no? Oh, this
Sorry. My answer is B option. -1 and 0.
minus 1 and 0. And this is so this is 2 and this minus 3. 2 and minus 3 minus 1 will get. This is 1. Okay. And this is 4 and minus 4. This is 0. Yeah, this is option B is actually correct. Yes.
Okay.
Yeah, this is C is given. This option B is should be correct.
Okay. And activity 7, question 4.
7. Okay. This one.
Yes.
Let this matrix with the matrix of T of 1, 2 is going to be just multiplication, correct? That's how
Yes,
if you
sir.
want to find here T of 1, 2 means just do the matrix multiplication. So this
Yeah.
is going to be 1, 4 means 1 plus 4 which is 5. So which option is correct here? C option
Both
and
both the answers are wrong. Like
okay.
A and D.
A and D. A. This is what it
I've
is.
got
Can you work
I've
it out?
got C option. Yeah. 5 and 8. It should be 5 and 8.
Yeah, just a matrix multiplication. This row will catch and multiply with this vertically here 1 2. So this is 1 into 1 plus 2 into 2, which is 5. Now we'll catch the second row and multiply vertically. This is 2 into 1
Plus
plus
3 into 2.
2, which is 2 plus 6, 8, which is surely the C option. This is not even the multiple select. Let me write it.
Yeah.
That is given multiple options, sir.
Yeah. Oh, this is not multiple select even. Let me write it. 2.9. This is 2.4. 2.7. Previously, which one is that? 2.9.
Activity 9, question 1.
Okay, thanks. Yeah, this is
Yeah.
this.
Actually, I have one more question.
Okay,
Activity 5, question 5. Question 4, sorry.
25 question 4. This one.
Question 4.
This one.
Yeah.
Okay.
Yeah.
Here is nullity is 0 actually. Yeah, this is. I have seen this in. I think you have this nullity. I don't know. This is 2.5. 2.
It should be 1, right? Not 0, I think.
Nullity is
No, that's 0 actually because column is not 0, right?
nullity is 0 because 0 only the 0 vector will go, because if it is sorry, y is independent. No, sorry, I just
Yeah.
missed in the group
Yes,
name.
rank is 1 and nullity is 1.
Yeah, I just missed that even in the group name. Okay, so this is y is a free thing, so nullity is going to be 1. Y is free here. If you equate it to 0, x is equal to 0 got, but y value is totally independent now. So y is independent means vector 0, 1 is a basis for the null space, and nullity is going to be 1.
So that's because one free variable actually.
Yeah, because of free variable. Okay. Okay, mock is all of you have gone through with the mock? Still going or bit small? Maybe we'll all of you gone through with the mock or is still going it or doing it? Have you tried this mock, all of you?
Still going through, sir.
Okay. Then probably we'll discuss on Saturday. Okay. So try it once. We'll discuss on Saturday. Even the all questions are okay. So some questions of of 2 and 4. So last time discussion. Only this span is there. This one is already of 3 and 4. This is one problem. Okay. Okay, try it. This will give an idea how to write. Even I will suggest you, if you once try yourself at home to write the steps, or even at least try to even solve this, will give more idea, and a kind of a practice also to even see. I am looking at here. The questions are from a basis change, invertible thing, and these are all actually we discussed. Nothing is there. This one already just now discussed. This is what just metric multiplication. Inverse is the way just now find the inverse, or it's asking invertibility means just find the rank. If rank is 2, then invertible. Just now discuss this composition, finding the inverse. These are long. We have this discuss. We have to spend more time on here. So try it. We whatever the thing is there, direct question is there. Directly you can solve. Okay. So try all. Okay. Thanks for joining. Anyone have any doubt? Still doubt?
So in exam also it will be directly related or something
Yeah,
indirectly.
direct only. Direct only. If you know it, that's whatever. That's why the mock is actually. I
Okay.
will not say the exact question or maybe matching question would be there, but the same pattern will be in the exam.
Okay. Thank you, sir.
Yeah. Thanks, everyone. Thanks for joining. We will see you on next revision session. There will solve. Thanks.